Okay, class, where we are now, we're looking at the autonomic nervous system. The autonomic nervous system. Okay? So the autonomic nervous system really means automatic neurons, to be honest. This is a nervous system that you don't have to think about. It controls your internal organs and things of that nature there. So let's investigate, see what we have. The autonomic nervous system consists of motor neurons that innervate smooth muscle, cardiac muscle, and the gland. They make adjustments to ensure optimal support of body activities. Okay? All right. Operate via subconscious control. Other names: involuntary, general visceral motor nervous system. Now, technically speaking, we now assign the autonomic nervous system a sensory division. And I'm going to put that in here. A sensory. That we call the visceral afferents. The visceral afferents. In other words, we say that if you have pain in your bladder, your intestine, so in other words, I'm now putting a sensory division there, and I don't know why the book didn't. And that's called the visceral afferent. So it's motor and sensory, but the main dedication, of course, is the motor part. And the motor part innervates cardiac muscle, smooth muscle, and the glands. Okay. Other names are the involuntary nervous system, the general visceral nervous system. Here's kind of the breakdown, but we already saw that. But the autonomic nervous system has two branches, the sympathetic and the parasympathetic. Anytime you think of the sympathetic, think of fear, flight, and fight. It's the excitement part. It would speed up the heart. Anytime you think of the parasympathetic, think of rest and recluse. It would slow down the heart, just using the heart as an example. So two divisions of autonomic motor. Two divisions of autonomic motor. Sympathetic, fear, fight, and flight. Parasympathetic, rest and recluse. Okay? The two systems differ in, this is the difference between the somatic and the autonomic. Now remember, somatic motor goes to skeletal muscle. Somatic motor goes to skeletal muscle. Autonomic motor, smooth muscle, and cardiac muscle, heart muscle. The two systems differ in the effectors they use, the efferent pathways, and the target organ responses to neurotransmitters. So there is a difference. Okay. Now look over here, for example. Here's the somatic nervous system. Here's a heavily myelinated neuron going to skeletal muscle, because skeletal muscle works fairly quickly. Smooth muscle and cardiac muscle works very slow. You can move your arm many times. The heart gets up to 100 or 200, and it's almost about to give out, at least to a 200. All right. So you have one neuron going all the way to the muscle, neurotransmitter acetylcholine. When we get to it, the autonomic nervous system is a two-neuron pathway. You have a first neuron and a second. See, in the somatic is one neuron. In the autonomic, a two neuron. And that's true for the sympathetic and the parasympathetic. Neuron 1, neuron 2, before you get to the effector. The effector is the organ. So one neuron for somatic, the autonomic is a two neuron pathway. Okay, that's one thing we'll look at. All right, effector, skeletal muscle, we already said autonomic, cardiac muscle, smooth muscle, and the glands. Okay, efferent pathways, that's the motor. A thick, heavily myelinated axon. See, that's for the somatic. It's quick. Autonomic, we have neuron 1 and neuron 2. Now, the technical name are preganglionic and postganglionic. Because what's going to happen is this first neuron is going to branch. Now listen to me now. This first neuron is going to branch in both cases and pick up a bunch of second neurons. So this first one, unlike shown here, is going to branch and pick up a bunch of them. So then that means you would have a bunch of neuron cell bodies in the peripheral nervous system. What is that? A ganglion. Pardon me, a ganglion. So the first fiber then, if that's a ganglion because of this, a bunch of them because of a ganglion, then this first fiber would be called the preganglionic and the next one would be called the post. So the preganglionic has a lightly myelinated. It's fairly quick, but not as quick as heavily myelinated. And it's thinner. Remember the two things to speed up nerve conduction? Large diameter and myelin. See, this is a larger diameter and it has heavy myelin. This is a thin diameter, lightly myelinated. So it's not as fast as this. And when it gets here, it picks up an unmyelinated. So the postganglionics are unmyelinated because what they're going to is something that's slow. Remember I told you, why send an overnight letter to someone who's not going to read it for a week? So ganglionic neuron is an audit that has an unmyelinated, okay, which is really also called the postganglionic. They call it the ganglionic neuron because that's the cell bodies belong to this one. But you'll hear a lot of time, I'm going to put ganglionic, I'm going to put in parentheses what you'll oftentimes hear, postganglionic. Postganglionic. That's the other name. So some will use ganglionic because the cell bodies, but most will use preganglionic post. Okay? So we go further. See where we are here. Terminology. Okay, I already talked about a ganglion is a group of cell bodies in what? The peripheral nervous system. We just said that. And a nerve is a group of axons. So we're talking about nerves and this. I left nucleus and tract out because that's in the central nervous system. Okay. All right, so we go further. All right. The neurotransmitters, all somatic motor neurons, what turns on skeletal muscle is acetylcholine. We've already talked about that, what turns on. Now, autonomic, preganglionic fibers secrete acetylcholine. Postganglionic fibers, it depends. Postganglionic fibers for the sympathetic secrete norepinephrine. And the postganglionic for the parasympathetic secretes acetylcholine. So if I look at the heart, what am I saying? Acetylcholine would slow down the heart and norepinephrine would speed it up. Norepinephrine. I don't know how many remember, we talked about the neurotransmitters and I said that norepinephrine, dopamine were, if you may recall, we said cyclic. They came from tyrosine. We called them the catecholamines because they had that catechola ring from tyrosine. Okay. So here's that same picture there. We're going to go a little further. Divisions of the autonomic nervous system. What do we have? The sympathetic division and the parasympathetic. Almost all organs, visceral organs, have dual innervation. That means some fibers from the sympa and some from the para. I said almost. For example, the kidney does not. The kidney has sympathetic, but it doesn't have parasympathetic. So we said almost. That means one would turn it on and the other would turn it off. And it just depends. You say, what do I mean by that? It depends. Let's do the heart. The fight or flight one, sympathetic, would speed it up. The parasympathetic would slow it down. But if I go to the intestines, it's diametrically opposite. Because intestinal activity is a rest and recluse. So in this case, the parasympathetic would speed it up and the sympathetic would slow it down. So it depends on what, is this an organ that's needed in rest and recluse, or is it an organ need in fear, fight, and flight? That's the way you want to do it, rather than just memorize. Okay, we go a little further. Okay. Role of the parasympathetic division: promotes maintenance activities and conserves body energy, rest and recluse. Its activity is illustrating a person who relaxes, reading after a meal. Blood pressure, heart rate, respiratory rate starts slowing down. Gastrointestinal tract is high because GI work is a what? Rest and recluse. Pupils are constricted. See, when you're excited, you want your pupils big so you can see what the heck is coming towards you. But in a restful situation, the pupils will constrict, and which will also cut out light where you can rest. Okay? All right, go a little further. Role of sympathetic division. Mobilizes the body during activity, is the fight or flight system. I also call it the fear, many call it the fear, fight, and flight. But anyway, promotes adjustment during exercises or when threatened. Blood flow is shuttled to skeletal muscles. So in other words, you vasoconstrict organs like the intestines. Then you take it to skeletal muscles. See, if you do an exercise, you would do it. That's why you kind of in a tizzy if you eat a big meal, then go swim. Because what's going to happen, particularly if you're swimming in a lake. See, if a pool, somebody can pull you out. But in a lake, you get halfway. Because if you ate a big meal, the intestine's trying to get a blood supply. But if you're exercising, it's going to cut it down to that. And you're going to cramp because the intestine's going to hold the food. Because you need to shunt it to the muscles. Bronchioles dilate, that's the respiratory. Liver releases glucose in order to give these muscles some energy. Okay? So, sympathetic. Now, what we're looking at now is where do these things come from? Okay. We'll come here. All right. The first cell body, now let me show you what we're talking about here. The first cell body, the original cell body in the central nervous system. The original cell body in the central nervous system, because that's where the first cell body is. If it's the sympathetic nervous system, it comes from the thoracolumbar region. So it's going to come from this area to here. That's where the first neuron cell body. Now I'm going to come here to something we did. That first, if it's the motor, that first neuron cell body would be there. See, this is visceral motor right there. It's going to be in that lateral horn. So that first cell body would be in the lateral horn. Listen to me, in the lateral horn, if it is sympathetic. This is showing just that part. But where would it actually be in the lateral horn? That's where the first cell body would be. Okay. Okay. The other thing, when it comes to the sympathetic, the first fiber, the preganglionic, see now they're using pre and post. We'll come here. The first, if it's doing sympathetic, the first fiber is short. That's the preganglionic. And the latter one is longer. Short pre and long post. Short pre and long post. That's the sympathetic. And the ganglia is going to be close to the spinal cord, we're going to see. And what you say, what does that mean? The ganglia is going to be close to the spinal cord because here's where that ganglia is going to be. See, right there, when we get further, that ganglia is going to be right there close to that spinal cord there. Okay, we're going further. All right. In the parasympathetic, it's going to originate from either the brain or the sacral area of the cord. From either the brain or what? The sacral area of the cord. Now in the brain, remember cranial nerves. We just did the 12 cranial nerves. So cranial nerves 3, 7, 9, and 10. Let me say it again. What cranial nerves 3, 7, 9, and 10 have parasympathetic fibers. 3, 7, 9, and 10. Only 4 out of the 12. And the other comes from the sacral area. Now, what this one has, in this particular case, is a long pre and a short post. A long pre and a short post. Okay, so we're going to pick that up again. See, it has a long pre and a short post. Okay, location of the ganglia is actually within the organ itself, that post. So we're going to close here and pick up again